Welcome all. Hope you all are on national duty. What do I mean by national duty? Staying back at home and preventing the spread of coronavirus. So I am on national duty since 17th night March. From 18th March to till date. Today is 29th. I did not go out of my house. So I request everyone to stay back at home, learn certain things through online, or just sit back, relax, enjoy with your textbooks or some material, whatever is available, and do some activities, some domestic activities. That's it. This is the only way to save. Today, I'm going to take up a topic which is on plane stress versus plane strain. This is one of the important topics in our mechanics of solids. Plane stress versus plane strain. Okay, first we'll see what is plane stress. Then what are the requirements to achieve plane stress conditions. Then we'll see what is plane strain. After that, we'll see what are the conditions required for achieving plane strain conditions. So, are they totally different or is there any link between them? We'll see it in detail with some practical examples. Okay. Now, chaliye. Let us take a member. I am showing you a stressed element. Okay. Right. Let this face be subjected to a stress sigma x. So definitely the opposite face is also under sigma x because it is in static equilibrium. Everything as the areas are same, stress must be same. Okay. Let this be sigma y on the top and bottom face. Let this be sigma z. Front and back. This is triaxial loading. Okay. Now, my principal directions are x, y, and z. These are my principal directions. Okay. See, plane stress is a condition in which the stress on one of the principal directions, stress in one of the principal directions is 0. That principal direction may be x, may be y, may be z. So for convenience, I take it as z. What does it mean? My dear students, you know, this is one face, this is one face, and this is the opposite face. Now observe here. If this face is not subjected to any force, or if it is not stressed, the opposite face is also not stressed. Okay. Now, let's see what is plane stress. Let the stress in one of the principal directions, say z direction, it can be x or y. So generally when we take one direction is neglected, generally we take xy, that is our convention. So let's take, it can be xz also, it can be yz also, but I am taking one of the principal directions z, stress in the z direction 0. Chalo, ab dekhte hain. Now, a member is subjected to sigma x, sigma y. See, note down that there can be tau also. There can be non-zero value of the shear stress on this plane. So if this is tau and all these faces, they have tau, tau, tau from the balance of moments and forces, you get that. Now, in this direction, that is Z direction, it is not subjected to any force. The opposite face is also not subjected to any force. So if the stress in one of the principal directions, say Z direction, is 0, then that is the condition of plane stress. So what is plane stress? In plane stress case, the stress in one of the principal directions is 0. Okay, now X direction, Y direction, Z direction, the stress is 0. Excellent. First we'll see plane. Okay, so sigma X need not be 0, sigma Y need not be 0, and sigma Z has to be 0. Sigma Z is 0. Okay, fine, no problem at all. No problem at all. This is the condition now. Okay. To achieve this condition, what are the requirements? Let us see. To achieve this condition, what are the requirements? Let us see. If you take a thin cylinder, let's take a thin cylinder with closed ends subjected to internal pressure P. Okay. When can I call a cylinder as thin cylinder? The condition is d by t value must be greater than or equal to 20. Okay. Look at this value must be greater than 20. Then we call it as a thin cylinder. For example, let this be the cylinder. Let this be the mean diameter d and the thickness is t. Means if the thickness is very small, if t is very small, if this value is very small, this value will be more. Okay, fine. So I have taken a condition where one of the dimensions, in this case thickness, is very small. Okay. When the cylinder is subjected to internal pressure, we have, please observe, when the ends are closed, it is subjected to longitudinal stress. And due to internal pressure, my complete circumference is subjected to hoop stress. It is when the cylinder is subjected to internal pressure, that pressure will try to open up the cylinder, So kya hoga? Because of that, the diameter increases. And when it is closed and subjected to internal pressure, because of that, the length tries to increase. So these longitudinal and circumferential stresses are tensile stresses. Now observe here. So we'll take this case, my dear students. Let's take this, understand carefully. I'll give you a simple example. Let us assume that this is the cylinder, ends are closed. So this is the closed end, this is the closed end. Let us assume this also closed. Okay, fine. Though ends closed, it is subjected to internal pressure. Because of that pressure, throughout the circumference, the diameter tries to increase. We call that as circumferential stress. And when the ends are closed, because of that pressure, it tries to increase, elongate. And you know, when it is along the thickness, let us say radial direction, circumferential stress or hoop stress, it tries to increase because of the internal pressure. The longitudinal stress will try to increase the length. So when it is, I'm talking about the internal pressure, when the cylinder is subjected to internal, not external. So, okay. So therefore, the diameter tries to increase, length tries to increase, means the diametral stress is tensile. That's why the diameter is increasing. The lengthwise stress is increasing. That's why the length is increasing. That's why this is also tensile stress. Lengthwise it is tensile, circumferential wise tensile. And you know, let us take this. देखो अंदर से now we have, look at, now there will be radial, along the thickness, radial stress, which is nothing but pressure. फिर से बता रहा सुनो, there is along this, along internal pressure, along this there is pressure throughout the circumference, pressure acting. So this is radial, which is pressure. Now let us see, my dear students, when we study thin cylinders, we can derive, when we study thin cylinders, we can easily derive the circumferential or hoop stress as PD by 2T, and the longitudinal stress is nothing but PD by 4T. No problem at all. We'll be deriving this, so no problem at all. No problem at all. Okay. Now the radial pressure is, radial stress is nothing but what? Pressure. Let us take B by T as some 100. Obviously, when it is greater than 20, we call it as thin cylinder. So which dimension is less? Which dimension is less? It is thickness, 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 thickness. No problem at all. Now have a look at this, my dear friends. Let us calculate the circumferential stress. So what will be the circumferential stress? Let it be subjected to an internal pressure of 5 megapascal. Let us take an example. So P is 5 megapascal by 2, okay, by 2, D by T. What is D by T? 100. So this will turn out to be 250 megapascal. This will be 250 megapascal. So the circumferential stress is 250 megapascal. What will be the longitudinal stress? Very simple. This is PD by 2T. This is PD by 4T. But the longitudinal stress is half of the circumferential stress. If it is 250, it will be 125. And the radial stress is nothing but pressure, which is already we have taken it as 5. Now have a look at this. My dear students, just observe here. So I'll show you like this. We'll take this. Yeah, dekho. This is the circumference along the circumferential stress, and this is the lengthwise longitudinal, and this is the radial. This is the radial. This is the radial, and this is means it is subjected to 3. Circumferential we have seen it as 250. The longitudinal we have seen it as 125, and the radial is 5. इसका मतलब क्या है? Whenever one dimension is very small compared to other two, this is very small. When it is very small, it can be neglected. When it is very small, it can be neglected. So when it is neglected, we have only 2. So in other principal direction, it is almost 0, almost negligible. So therefore, now you are left with only these 2. What are those? That is 250, and this is, both are perpendicular, and this is 125. And in the z direction, it is 0. In the z direction, it is 0. So therefore, this is nothing but, when the stress in one of the principal directions is 0, it is nothing but plane stress condition. So for achieving plane stress condition, one dimension must be very small. If one of the dimensions is very small, for example, thin cylinders, the thickness is very small, so we can take it as what? Plane stress condition. So for plane stress condition, one dimension must be very small, so that we have majority of stresses in this direction. So the third direction, z direction, देखो मैं बता रहा हूँ, सुनिए. Now let's have a look at this. Okay, I'll take the element and I'll show you. Okay, on this, let me draw the element. Can you see? एक second. Yeah, very good. So एक बार देखना. Yeah, look at, this is lengthwise. I'll take other color so that you can see easily. This is lengthwise. This is longitudinal. This is circumferential. This is, देखो ये circumference क्या करना, अगर आप कट करेंगे, it is trying to open up. So this is circumferential, and अंदर से जो आ रहा है radial z, this is x direction, this is y, and z direction अंदर से जो pressure है, this is my z direction. So this is equal to, radial is equal to pressure. वो तो बहुत negligible है, it is very negligible. In this direction it is p negligible. This is longitudinal, lengthwise we got it as 125. This is circumferential, we got it as 250, and this is just 5, mean this is negligible. So in this direction, I repeat, in this direction, the pressure z direction, it is 0. Not 0, but very negligible compared to this. So therefore, ये stress बहुत negligible है, leave it. So we are left with only these two, x and y. So in this direction, z direction. So देखो एक बार, इस direction, z direction, it is almost negligible. X, Y. So therefore, a thin cylinder subjected to internal pressure is an example of plane stress, plane stress, plane stress. Okay, now we'll see, my dear students, now we'll see what is plane strain. उसके बाद we'll start comparing. It is a condition in which the strain in one of the principal directions, say X or Y or Z, is zero. I repeat, it is a condition in which the strain in one of the principal directions is zero. देखिए एक बार, understand carefully. Have a look at this. My dear students, let us take for example rolling. In metal forming, you'll be studying rolling. This is the thickness. ये thickness है और ये है width है. This is the thickness. And you know the width is very large compared. देखो, in plane stress, one dimension is very small. But in plane strain, the strain in one of the directions must be zero. To achieve that, what is required, we'll see. W is very much larger than thickness. One dimension is very large compared to other. This thickness is very small. देखो, when it is rolled, thickness is changing. So I will write the strain in the thickness direction as change in thickness to the thickness. As the thickness is very small, this strain in the thickness direction is appreciable large. Means there is a strain in this direction. Now let us find out strain in the width direction. Strain in the width direction, change in width to the original width, and this W is very large. When one of the dimensions is very large, अगर ये बहुत large होता है तो ये negligible होगा. Strain will tend to zero when one of the dimensions is very large. अगर ये बहुत कम होता है, if this is very very small, I repeat, if this value is very small, if this value is very very small, this will be appreciable. It is not zero. तो strain zero होने के लिए, here zero means tending to zero, almost zero. तो अगर ये डायमेंशन बहुत ज्यादा है, if this is very very large, then this value will be, जब width बहुत ज्यादा है, if this is very large, this will be negligible. So therefore it will tend to zero. So to achieve the plane strain condition, what do we mean by plane strain condition? The strain in one of the principal dimensions is zero. वो कब possible होगा? It is possible only one of the dimensions is very large. So देखो the difference. Plane stress के लिए one dimension should be very small. Plane strain के लिए one dimension should be very very large. So example is rolling. Rolling में width is very large compared to thickness. As the width is very very large, even though there is a change, it is negligible. Strain is almost negligible. So to achieve plane strain condition, strain one dimension should be very large. Example rolling. And what is the example for plane stress? Thin cylinders. In thin cylinders, one of the dimensions is very small. So therefore, the stress in the Z direction is almost negligible. Excellent, my dear students. Now we will see. So what is plane strain? It is a condition where the strain in one of the directions is zero. Chalo. Now observe here. One second, please. Yeah. Okay, now observe. We know that from our basics on SOM, sigma epsilon z, rather I would say epsilon z. देखो एक बार, it is all okay, कोई दिक्कत नहीं. हाँ, we'll take this color, I think. चलो, epsilon z is equal to sigma z by E minus nu by E into sigma x plus sigma y. This is my fundamental equation. This is my fundamental equation. So there is no problem at all. No problem at all. Excellent. Now look at, for plane stress, one of the stresses, say sigma z must be 0. See carefully, for plane stress, sigma z is 0. For plane strain, epsilon z is 0. अब देखना, so when I put sigma z, ये please इसको थोड़ी देर के लिए keep quiet, so don't use this. We'll talk about plane strain later on. Now look at, now this is plane stress. Okay, so if I put sigma z 0, now tell me, when I take plane stress condition, sigma z 0, am I getting epsilon z 0? Need not be. फिर से बता रहा सुनो, is plane stress condition leading to plane strain or vice versa? Let us check. मतलब क्या plane stress condition plane strain को lead कर रहा है या फिर plane strain plane stress को lead कर रहा है? Let us see. Is it true or not? Let us see. So let us take plane stress. For plane stress, sigma z is 0. When sigma z is 0, epsilon z is minus nu by E into sigma x plus sigma y. Oh my God, this value may be 0, may not be 0. Means plane stress may lead to plane strain or may not lead, but not compulsory. ऐसा कोई जरूरी नहीं है कि when a system is under plane stress condition, it is also under plane strain. गलत. It may or may not. We'll see what is the condition, or rather what are the conditions for simultaneous occurrence of plane stress and plane strain. So the beautiful point here is plane stress may not lead to the occurrence of plane strain. So कैसे? For plane stress, sigma z is 0. Plane stress, sigma z is 0. When sigma z is 0, epsilon z. So ये आ गया. तो प्लेन स्ट्रेन के लिए क्या जरूरी है? दिस शुड बी 0. बट ये 0 हो सकता है या नहीं भी हो सकता है. Similarly, let's take plane strain. Listen, my dear students. Let's take plane strain. Okay. Now, what is plane strain? Let us see. And you know that epsilon z is equal to sigma z by E minus nu by E into sigma x plus sigma y. Excellent. Plane strain ले लेंगे. Let's take plane strain. For plane strain, one of the strains must be 0. Let us say epsilon z is 0. So now tell me, plane strain के लिए this is 0. When this is 0, we have sigma z by E minus nu by E into sigma x plus sigma y. So therefore, so this E will come this side. So sigma z is equal to nu plus sigma x plus sigma y. ध्यान से सुनना. Whenever the system is under plane strain, sigma z may be 0, may not be 0. मतलब ये value, अरे यार, when this is 0, which is nothing but plane strain. When this is 0, it is nothing but plane strain. But plane strain may not lead to plane stress. Already we have seen plane stress doesn't lead, not necessarily. Plane stress में है, तो it may not lead to plane strain. Similarly, plane strain may not lead to plane stress. Both are totally different. And don't think that when the system is under plane stress condition, it is also under plane strain condition. Galat. May or may not. Not necessary. Similarly, when the system is under plane strain, it may or may not be under plane stress. So both are totally different. Matlab, a system under plane strain may not be under plane stress. Matlab, sigma z 0 nahi ho sakta. Even though epsilon z is 0, sigma z need not be 0. Similarly, when sigma z is 0, epsilon z need not be 0. So plane stress, plane strain are totally different. Now let us see the condition, or rather conditions, for simultaneous occurrence of plane stress and plane strain. Now, it's a beautiful, let me give some golden points. Now, I write simultaneous occurrence of plane stress and plane strain, मतलब दोनों एक ही साथ होना है, एक ही साथ होना जरूरी नहीं है. There is no guarantee or there is no need for both to occur simultaneously. But let us see what are the conditions to achieve both occurring simultaneously. दोनों एक ही साथ कब होंगे, एक बात देखेंगे. Look at epsilon z is equal to sigma z by e minus nu by e into sigma x plus sigma y. Excellent. Look at. Now let's go for plane stress, and for plane stress sigma z is 0. When sigma z is 0, epsilon z is minus nu by e sigma x plus sigma y. मुझे बताओ, already it is under plane stress. If you want under plane strain, this should be 0. This is 0. We have two cases. I repeat, my dear students, plane stress sigma z is 0. Now I want plane strain also, simultaneous occurrence of plane strain. तो क्या होगा? तो already sigma z is 0. Okay, epsilon z. I want this also 0. When is that possible? When nu is equal to 0. When Poisson's ratio is 0, epsilon z is 0. The next condition is, so let us assume this is not 0. अरे एक possibility क्या है? अगर if this is 0, automatically this is 0. The second possibility is sigma x plus sigma y is 0. Now either this के अगर nu 0 है तो automatically this is 0. Already this is plane stress, then this is 0, it will be plane strain. So plane stress, plane strain simultaneously will occur when the Poisson's ratio is 0 or when the summation of sigma x sigma y is 0. तो second case क्या है? अगर इसका sum 0 है, इसका sum 0 है, that is when this is 0, already sigma z is 0 because it is plane stress. So already it is plane stress sigma z is 0. If this sum is 0, this will also be 0. So to occur plane stress and plane strain simultaneously, two conditions are, any of these two conditions. One, either the Poisson's ratio is 0 or sigma x plus sigma y is 0. Now let us take the other one. देखो एक बार. Sigma epsilon z is equal to sigma z by a minus nu into nu by a sigma x plus sigma y. Okay, no problem at all. Now let us take plane strain. If it is plane strain, epsilon z is 0. Plane strain. So when epsilon z is 0, तो ये क्या होगा? When epsilon z is 0, it is sigma x by e, minus nu by e into sigma x plus sigma y. Okay, no problem at all. So one second, please. Right. This is sigma x plus sigma y. Okay. Now, look at. Don't worry. चलिए. So, for plane strain, epsilon z is 0. When epsilon z is 0, 0 is equal to sigma z by, okay. Now, this can be written as sigma z is nu into sigma x plus sigma y. Okay. Now, look at carefully. Already it is plane strain. Now, I want the simultaneous occurrence of plane strain and plane stress. Already it is plane strain, it is 0. But now I want plane stress. तो क्या होगा? This term should be 0. Again, if you want sigma 0 to be 0, so either nu should be 0 or sigma x plus nu should be 0. Either nu should be 0 or sigma x plus sigma y must be equal to what? 0. So I repeat, my dear students, understand carefully. So please observe conditions very clearly. So already it is under plane strain. For plane strain, epsilon z is 0. And if you want sigma z to be 0, again there are two conditions. Either nu can be 0. When nu is 0, this value will be 0, or summation of this must be equal to what? 0. So therefore, for simultaneous occurrence of plane stress and plane strain, either the Poisson's ratio must be 0 or sigma x plus sigma y is equal to 0. So intelligently the question can be framed in examination. Let's see what can be that. He gives this, okay, एक बार देखना. Sigma x is 20 megapascal. Okay, sigma y is 20 megapascal. Sigma y is 20 megapascal, and already it is under plane stress condition, because in one of the principal directions sigma z is already 0. Sigma z is 0. So it is already in plane stress. He says an aluminium member is subjected to a stress system as shown in the figure, and for aluminium nu is not 0. Nu is not 0. Okay, now can we write sigma epsilon z as sigma z by A minus nu by A into sigma x plus sigma y? Yes, you can write. Yes, you can write, no problem. देखो एक बार, what is sigma x plus 20? Because it is tensile. What is sigma y? It is compressive. Therefore minus 20. Now can you tell me what is sigma x plus sigma y? That is 20 plus of minus 20, which is 0. Means already it is plane stress. Already it is plane stress. So this, therefore sigma z is 0. Sigma z is 0 minus nu by A. Just now you found sigma x plus sigma y as 0. So therefore this is also 0. Matlab epsilon z is 0. When epsilon z is 0, it is plane strain. Already it is plane stress. Therefore it is plane strain. Likewise, he may be asking in one of the objectives, which one of the following options clearly shows the simultaneous occurrence of plane stress and plane strain? If nu is not 0, then you check sigma x plus sigma y. If sigma x plus sigma y is 0, then you can easily say it is a case of not only plane stress but also plane strain. So please understand things clearly, they are both different. So plane stress may or may not lead to plane strain. So in the next class, coming class, I'll tell you what is the relationship between different shear stresses and different normal stresses for plane strain and plane stress condition. So thank you, and please stay at home, just revise things, learn to the maximum, don't go out, enjoy with your subject, fall in love with your subject. Thank you, and I am coming up with one more lecture, that is second law efficiency, first law efficiency, how we use second law efficiency in heat exchangers, how we use second law efficiency in compressors. All those I'll be coming up with the next video. Thank you, God bless you, love you all.